9-2 in advanced geometry. We're going to do some reflections and some dilations today. The hardest part about it is honestly like reading it. We learned last time that the lowercase r stood for reflection, and here they're asking me to like reflect point A, but they put this little subscript right here. That's a cursive L over line L. And what I want to do on this first one, which is not on your worksheet at all, right? I just want to like totally take some guesses before we measure things out and all that crazy stuff. Like if I want to reflect A over line L, what do you think about A prime going down there? Do you think that would be correct or incorrect? What do you think? Yes or no? Doesn't look right, right? Because if I connected those together, it's like, hey, this distance and this distance don't really look the same. Doesn't the pink one look a little too long for the green one? So what if I moved it a little closer? What if A prime, what if those were perfectly the same? Would that be good or still not good? What do you think? Good or not good? Where should this guy be? I think you get it. It should be like right here. Like, you know, to like totally be right there. Why does it have to be right there? Talk to a neighbor. What do you think about if I connected these together with a segment? What's true about this segment in relation to this line? Yeah, we got to vote for this angle right here should be perpendicular. How do you feel about that being 90 degrees? And what do you think about this distance in pink compared to this distance in green? What do you think? They should be the same. Like if this was 1 inch away from the line, shouldn't it be 1 inch away from the line on the opposite side of it? So that is the definition of reflection, which is definitely on your worksheet at the top. The hard part is writing it. I'm going to say it in English, but it's written in math. I'll scoot this up so you can see it a little better. It says, if the reflection of A over line L is A prime, notice how it's written, is A prime, then L is the perpendicular bisector of segment AA prime. Just like you told me right here, like this guy's got to be 90 degrees for that to be reflected correctly, and this segment AA prime that I highlighted in green right there, like it is boom, boom, bisected as well. Line L, the line perpendicularly bisected that segment that was made up by those guys. So
okay, so now we're going to show you how to use your geometer to do a reflection. So the very first thing, you see this black line that is drawn on your geometer. If you don't have that, let your teacher know. We'll get that black line on there for you, but this is what we're going to do. We're going to take just the straight edge of our ruler and we're going to extend the line that we're reflecting over very much longer. How long? The whole stinking way. We want to keep this nice and long to keep us perpendicular. Then take your geometer, turn it to where the black line that we just made is going on top of the line that we just did very much longer. But at the same time, see this centimeters edge, not the inches, but the centimeters edge, we're going to line it up with point A. That's what we're reflecting over. So we're going to make sure that our black line's nice and on top of there. See, she's a little off. So get her all nice and lined up. That keeps us perpendicular. And then we just count how many tick marks are we away from the line. So notice they're grouped in 5. So here's 1, 2, 3, 4, 5, 10. Looks like about 14 or 15. It's pretty darn close. What that means is now we'll go that far on the other side of the line. So 5, 10, about 14 or 15. Put a point there and call it A prime. That's got the little apostrophe on it. Then we're going to do the same thing for B and C. So we reline our geometer back up. Black line, nice and on top of the line we made longer. Centimeters edge, all lined up with point B. And then we'll count how many tick marks away is it. So it's about 16. So we're going to go about 16 on the other side. So there's 5, 10, 15, 16. We're going to call that B prime. And then we'll do it for C. So the main thing is we got to get that black line lined up nice and straight on top of there. And then we're just measuring how far away it is on one side. We'll go on the other side. And then to connect these together, you just take your straight edge and connect the dots and you get a triangle. The video should explain the rest to you, very simple, but it's just something that you had to see. You had to see how to get that black line on there. If you still need help, please email your teacher, let us know, and we will help you out. Thanks.
They're going to ask you a lot about orientation. So first, it's like, what does orientation mean? It means like, which way around the clock are you going? Are you going clockwise or are you going counterclockwise? Hey, I know in 2025, not everybody understands how to read one of these old school clocks. Do you know that clockwise means going this way around, though? Are you cool with that? So clockwise, counterclockwise is the opposite way. So if I called this triangle ABC, like the original guy, and I just drew an arrow, please draw the same arrow with me, go from A to B to C, like because I went ABC. Hey, which way is that guy going? Clockwise or counterclockwise? So let's put counterclockwise, CCW, counterclockwise. Then they're going to say, well, how about, since I went ABC the first time, you have to go in the same order on the other one, but it's going to be primed. So how about A prime, B prime, C prime? Let's draw that. What do you think? A prime, B prime, C prime, is it clockwise or counterclockwise? Clockwise. So they're going to ask you this. What happened to orientation? Was orientation the same or reversed? It was reversed. And if you think about it, isn't a reflection just a flip it over kind of thing? So that makes perfect sense. It's like, oh, the orientation should be reversed because I just totally flipped this guy over. So that's a reflection. Let's do another one here. First, let's reflect this guy over line N. So let's make it long this time. It's cool that you go into other questions, right? If the line that you extended out longer goes into other questions, no big deal. Make it very, 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 very long. So take your straight edge, extend out line N. Don't go erasing that either. I grade that. If you don't extend the line, I can't give you credit for these because there's no way that you stayed perpendicular. Your thing's going to be off just a little bit. So let's just start. Put your black line on top of there and line them up with A and reflect A over. So A prime should be over there. I put them all up because people start freaking out. They're like, I don't think this is where B prime should be or where C prime should be, etc. So that way you can see it as you do it. Like, it's totally, totally going to be okay. The hardest part is putting your dot for your point versus your prime, which is like in a little apostrophe. So if you make them too similar, you'll get confused of how you connect these together. So I always try to make a big fat dot for my point and like a skinny little apostrophe for my prime. So everything should line up. You got A prime, B prime, C prime, D prime, F prime. And if they don't line up, you didn't have your line extended out long enough, or you mismeasured. Like if this was supposed to be 1.2 centimeters, you may have made that 1.7 centimeters or something like that. And you can tell that mine's not perfect either because doing this on a computer screen is definitely not an easy thing to do, right? So mine's not perfect in that matter. But what do you think? There are like 4 things preserved by every single reflection. It's called the ABCD postulate. And the reason why they call it the ABCD postulate is because those 4 things start with the letters A, B, C, D, and etc. So here's my first question. Let's pretend this was 30 degrees. You don't need to put that in your picture. But if that was 30 degrees, when I reflect it, what should that angle measure right there? 30 degrees. You know why? Because angle measure is preserved. Angle measure. Angle measure is preserved by every reflection. If the original guy is 30 degrees, the new guy is going to be 30 degrees. Talk to me about like this. When I highlight this dude right here in orange, is B between A and C? Yes or no? Yes? So when I do this new guy over here, do you think B prime should be between A prime and C prime? B stands for betweenness. Got to be spelled correctly also. B-E-T-W-E-E-N-N-E-S-S. Double the E, double the N, double the S. Betweenness is preserved. These are test questions, by the way. You'll see this 5,000 times between now and test day. What are 4 things preserved by every reflection? Angle measure, betweenness. C is the tough one. How do you feel about these 3 points right here? Did they all line up? Yes or no? Did they all line up? Starts with a C. What's that word that means they all line up? What? Collinear. Do you think A prime, B prime, C prime should be collinear? If A, B, and C are collinear, then shouldn't these be collinear also? So the C word is collinearity. It's the word collinear. Collinear with an I-T-Y at the end. Collinear, collinearity, collinearity. And then D, if this measured 2 inches, what do you think about this? How much should that measure right here? 2 inches. Take a wild guess what D stands for. The distance is preserved. Distance is preserved. The ABCDs angle measure, betweenness, collinearity, and distance. Yes, they have to be spelled correctly for you to get credit on your test. And it's 100% a test question. It is also a quiz question as well when we take our quiz. So the ABCDs. Then those are called something special. Those are called an isometry. An isometry is a congruence transformation. That's all you got to put is what's in this pink box right here. A congruence transformation. If you preserve angle measure, betweenness, collinearity, and distance, you will stay the same size, same shape. You will be an isometry. Isometry. So let's talk about things we did on skill check today. We did reflections. Are reflections in isometry? Do they keep things same size, same shape? Yes or no? Yes. What about a translation? Is that an isometry? Will angle measure, betweenness, collinearity, and distance, aka will they be same size, same shape? Dilation. Is a dilation an isometry? No sirree, Bob. Cool. So let's do another one. In the picture at the right, what is the orientation of triangle XYZ? I would like you to draw an arrow for that. How do you connect them together? Go from X to Y to Z, baby. Let's draw this guy from X to Y to Z. What is the orientation of that guy? Counterclockwise, which you're always able to abbreviate. What would be the orientation of its reflection image? Clockwise. Don't even have to do it, right? It's just, it says what is not preserved by a reflection. That would be orientation. Orientation is not preserved. Reflections preserve angle measure, betweenness, collinearity, and distance, but they do not preserve the orientation of these guys. What do you think? Not too bad? Let's try again. Please, first of all, what does this say? I'll highlight, you say it. What is that? Draw what? The reflection, and then you just say the green thing of A, B, C, D, E over line AB. Please extend line AB out very much longer. And let's get one thing out of the way once we extend that thing out longer. They want us to reflect A, B, C, D, E over this line. Let's start with A. Where is A located in relation to the line we're trying to reflect over? It's on it, right? So somebody said 0 units away. Would you believe it is 0 units away from the line? Should we put an A prime? No. If the point is on the line, we don't have to reflect it. We don't get a new point. Is there any other points on the line? B. So your job is to reflect C, reflect D, and reflect E, right? Reflect those 3 points, and we will connect them together. So we just had to reflect C prime, or C, D, and E to get C prime, D prime, and E prime. And then even though I did this last time, I'm going to do it again. Way off, right? Way off. What did I do wrong? Did I reflect wrong, or did I connect wrong? Connecting the dots wrong, right? All my points are correct. My C prime, my D prime, my E prime are correct. But when you want to connect them together, if A is connected to E in the original, A's got to connect to E prime in the new guy in that case. So it's easy to do, man. It's easy to mess up. So make sure that we go boom to boom to boom to boom. Not too shabby, eh? Just doing a reflection. Definitely not a computer question, though. It is very pencil and paper-like. Please do number 6. Extend the line out very much longer and get her done. The video. The whole reason that I put this question on here, because people used to freak out back in the day that like A and B are like on the left side of the line and C is on the right side of the line. It doesn't matter. Right? It's like when you reflect, they'll go to the other side. So this is what she'll look like when you get there. B went to B prime, A went to A prime, and C went to C prime in that case. So. And then once you get those done, you can do 7 and 8 about the orientation. Orientation. I like to draw the arrow just of the original guy when they ask about orientation. What's the orientation of triangle ABC? It's like you have to go around the way they name it, you know? It's like, because you could call it CBA and it would reverse the orientation, like if they call the triangle CBA. But since they called it ABC, you got to go from A to B to C in that case. So whatever they name it, that's the order you go around in. And that bad boy is clockwise, which means that A prime, B prime, C prime should be reversed of that, of counterclockwise. Those are reflections. 4 things preserved: angle measure, betweenness, collinearity, and distance. What is not preserved by this guy? Orientation. The way you go around the clock is orientation. Feel okay with that?
And then lastly, we've got ourselves a floor plan of an apartment complex below. They say what transformation, that means like reflections, rotations, or translations, or even dilations, did the architect use to design the complex? Well, can you see that there's like a mirror image going right across this guy? So that would be a reflection, baby. Like everything over here totally maps to this over this magical line right here. Just a beautiful reflection over the red line. So, transformations. Let us know if you have any questions. Have a good one.